For a positive integer n, let Pn denote the product of the digits of n and Sn denote the sum of the digits of n, the number of integers between 10 and 1000 for which Pn plus Sn equal to n is. So n here is between 10 to 1000, which means either it is a 2-digit number or it is a 3-digit number. How do we write a 2-digit number? We write a 2-digit number as 10a plus b, and a 3-digit number we write as 100a plus 10b plus c. So let Pn be the product of the digits of n. So first case, case 1, if n is a 2-digit number, if it is a 2-digit number, then Pn product of the digits will be a into b plus sum of the digits, which is a plus b, equal to number which is 10a plus b. That is a plus b plus ab equal to 10a plus b, or we can write that 9a equal to ab or b equal to 9. So if I take b equal to 9, I can take any value of a from 1 to 9, because the number here is 10a plus b, where a is any natural number, only then it will be a 2-digit number. So a can take any value from 1 to 9. So 9 such cases possible. Case 2, this was case 1. Case 2, if n is a 3-digit number, if it is a 3-digit number, then it will be 100a plus 10b plus c. So product of the digit is a into b into c, plus sum of the digit will be a plus b plus c, should be equal to number 100a plus 10b plus c. This gets cancelled. Now this is ABC equal to 99a plus 9b. So there is no such values of ABC which will satisfy this condition. No such values of ABC that will satisfy this condition. So no cases, 0 cases here. Okay, which mean there are only 9 such numbers possible.